Alright, so I'm going to be working on a rotation of a rigid body problem and finding the velocity at point D. So a couple things to note, and it's going to really help us out because we're going to be using the general formulas for velocity and acceleration to the right here. So a couple things are going to help us reduce these general equations into much easier, simple formulas to use. So the question gives us the angular velocity. The question tells us that this rigid body is rotating about the AB axis, which means that the angular acceleration is going in that direction, and the angular velocity is also going in that direction. And also, it's important to keep in mind that the vector for the angular velocity is always going to be perpendicular to the rotation, or perpendicular to the plane of rotation, or if you use the right hand rule, point your thumb in that direction. As you rotate, you can see that the vector is going in the same direction as the axis at which the rigid body is rotating on. So the formula goes as follows. The velocity at D, remember we're looking at point D, is equal to the velocity at any point that we want to observe plus the angular velocity cross the position of D relative to that position that we're looking at D, plus VRAL. And so the question becomes, at what point do we want to look? If we look up here, let's say we're looking at D in this direction, or we can also look at D in this direction, or we can look at D move, the position of D move at this direction. It really doesn't matter, we just have to pick a point. And the easiest point, given that it's rotating about AB, it's rotating about AB, that means that the velocity at any point on AB would be 0. So it's easy to choose. It would be easy to choose either point A or point B. And I'm just going to choose point B. So that means that we're looking. This is my drawing of glasses. So we're looking at D from position B. So let's write a little B here and a B here. Now, let's see if we could simplify this equation a little bit more. We said that the rotation, any point on the rotating axis, or the axis at which the rigid body is rotating on, is going to be 0, and B is on that axis. So we could say that VB is equal to 0. Now also, if we look at this note here, that if 2 points are on the same body, the relative velocity is equal to 0. So that means that VREL is equal to 0. So now we can say that VD is equal to the angular velocity across the position vector of D relative to B. So all we need to do is find these two vectors, do the cross product, and we will be done. So let's find these vectors. We can recall that a vector, let's see, we'll do it up here. Let's say vector u is nothing other than the magnitude of that vector multiplied by the unit vector in the direction of u. So the angular velocity would be the magnitude of the velocity, which we know is to be 5 radians per second, multiplied by the unit vector. We can also recall that a unit vector is equal to, and let's just be more specific, the unit vector of AB is going to be equal to the vector AB divided by the magnitude of that vector. So this would be W multiplied by AB divided by the magnitude of AB, which is equal to 5 radians per second multiplied by AB. Let's see, AB, vector AB would be, we're going to be on the Z Y plane, so X would be 0. Y would be, let's see, we're going to go down 8 inches. And then we're going to go positive 6 inches in the Z direction. And then we're going to divide that by the magnitude, which is just 8 squared plus 6 squared. So therefore, the angular velocity would be and this is, we're going negative 8 in the y direction. So negative. This vector would be 0. Negative 4. And 3. So now we have this vector right here. Now let's see if we can get the position vector of D relative to B. Now remember, since we're observing the motion of D from the position B, it makes sense that we're going to look at this vector starting at position B. So we're going to go positive 7 in the x direction. and then we're going to go 0 in the y direction, and then we're going to go -6 in the z direction. That one was pretty simple. So if you recall that the cross product nothing other than the determinant, where this would be W and position D relative to B. This would be 0, -4, 3, 7, 0, and 6. So can conclude that the velocity at D is equal to, now I'm just going to use my calculator because this is not a math problem, so we can definitely use our calculator to do cross product of vectors. And we have to note that we're going -6 in the z direction. Sorry about that. Good thing I caught it here. This would be negative. So now we could do the cross product. And come up with the velocity at point D in this instant is 24, 21, and 28 inches per second. And there you have it. We found the velocity of this object, this rigid body, rotating about some line AB.